This video is about page 6 of the notes packet. Today we're going to be discussing representing ionic bonds. So we're drawing today. Okay, so sometimes you're going to be asked to draw a model depicting how bonding is going to occur between two elements. So for example, in this box down here, I'm going to be talking about how magnesium and chlorine would bond. So first thing you need to do before you do any sort of drawing is you need to think about what type of bond is going to be occurring. Okay, so if you think about magnesium, magnesium is on the left side of the periodic table, which means it's going to have it's going to be a metal, whereas chlorine is on the very far right side of the periodic table, so it's going to be a non-metal. And we know that there's a general rule that we can follow in my class that metals and nonmetals coming together is going to make an ionic bond. So that means I can follow the rules I'm about to show you. So step 1, draw the Lewis structure for the metal atom. So I'm going to say, okay, well, magnesium has 2 valence electrons. Then, number 2, I'm going to draw the Lewis structure for the non-metal atom. So I'm going to go ahead and I'm going to write down chlorine. And I'm going to look at my periodic table. And I'm going to remember that chlorine is in column 7A, or 17, which means it has 7 valence electrons. So I'm going to go ahead and start drawing my 7 electrons around my chlorine. Now that I have that, step 3 tells me that I'm going to draw arrows from the metal's valence electrons to the non-metal atom's single electrons. So what this means is I'm going to draw an arrow giving this guy a roommate or a buddy. Okay? Now, what this means is, hey, this electron is now with chlorine. So I'm going to count how many electrons chlorine has. 1, 2, 3, 4, 5, 6, 7, 8. Okay, if you remember, 8 is that lucky number, okay? 8 is that number of stability. So chlorine, he's chilling right now. He is happy because he has his full octet. But if I look over here at magnesium, it did get rid of 1 electron, but it still has a pesky little electron sitting there. Magnesium is not stable or low energy right now because it still has this random electron floating in its outer shell. So here's what I'm allowed to do. I'm allowed to say, well, hey, another chlorine atom who has 7 valence electrons could come around and say, yo, give me your electron. And what's going to happen is magnesium is going to say, okay, fine, take it. And now this chlorine is happy because he has a full octet. And this chlorine over here was already happy because he had a full octet. And now look at magnesium. Magnesium is feeling stable because magnesium's new outer shell was that other shell that already had a full octet. So this is how the ionic bonding is going to happen. So really what's happening here, you have this bare magnesium that has a 2+ charge, and it is feeling attraction, okay, to 1, 2, 3, 4, 5, 6, 7, 8. To 2, oops, sorry, I did not mean to do that. Dang it. To 2 of those chlorines, okay? And honestly, there's a few ways you could probably draw this. I actually don't know what I prefer for you. Okay, but the point is there's that electrostatic attraction happening there. And so the formula for this would be MgCl2 because you have 2 Cls. And you can see a great example down here with sodium and chlorine bonding. So yeah, that's it.